Okay, to complete 22, you can look at this a couple of ways, but if you ever have a fraction and they have negative exponents to begin with, I would start by getting your exponents all to be positive. So as I evaluate this, I'm going to put a fraction sign. I'm going to look at each piece. X to the negative 1, that's a negative exponent. So since it's a negative exponent, I need to make it positive by moving it across the line and changing the sign. So this becomes x to the first. Now if I look at the bottom, the 4 does not have a negative exponent, so it can stay on the bottom. And x to the fourth is not a negative exponent, so it stays on the bottom. Since there's nothing left on top, put a 1 as a placeholder. So now you can do a couple of things. First of all, if you ever have just a number, it usually comes first. So that would mean that moves x1 here and x to the fourth. You can do that because multiplication is commutative and you can move things around. But now, if you have the same bases and they're being multiplied, this is the property of multiplication of exponents. So we have x, which is the same base as this. So you do x 1 plus 4, which would be 5. So you have 4x to the fifth, and that stays as 1. And that's it. Alright, on number 24, you have a fraction, but nothing is negative, so I don't have to move anything. So there is a property, if you look on your chart, and it says to subtract the top minus the bottom if the bases are the same. So I have m to the fourth and m to the fourth. So I'm going to do m to this 4 minus 4 on the top. That 2 stays on the bottom. Let me go over that real quick. The rule said if I had like x to the fifth over x to the third, that's the same thing as doing x to the top exponent minus the bottom. So I did the top exponent minus the bottom. So to simplify that, 4 minus 4 would be 0, so m to the 0 over 2. Another property, anything to the 0 power is 1, so m to the 0 power is 1. So 1/2 is your answer. Let's look at 26. Got a lot of things going on 26, but just take your time with it. So 26, first of all, I have negative exponents, so I'm going to get rid of those. So take each piece and decide what you're going to do with it. The 2 does not have a negative exponent, so it stays. X to the fourth is not a negative exponent, so it stays. Y to the negative 4 is negative, so it moves to the bottom and becomes positive. Z to the negative 3 is negative, so it moves to the bottom and becomes positive. Now go to the bottom. 3 does not have a negative exponent, so it stays. X to the second does not have a negative exponent, it stays. Y to the negative 3 is a negative exponent, so I move it up and make it positive. And Z to the fourth is positive, so it stays. So now we have to clean this up a little bit. First off, look at your top and see if anything will go together. Nothing here will go together because x and y are different bases, so I can't do anything to their exponents. So it stays 2x to the fourth, y to the third, over. Looking at the bottom, the only thing that'll go together are the z's. So I'm going to bring the number out in front. I'm going to put x squared, y to the fourth, because they don't go to anything. They don't go with anything, so I'll just write those down. And then z to the third, z to the fourth. This is the same base and they're multiplying, so that's z to the seventh. Now I'll simplify. I have x's on the top and bottom. So everything else, I can reduce my x's and my y's. So x, if they're stacked, I subtract. So that would be x to the 4 minus 2. that takes care of these. Y to the third, that becomes y to the third minus 4. Because 3 minus 4. And then z to the 7th doesn't go with anything, so I'll keep it z to the 7th. I want to go over here just for room purposes. So that's going to be 2x to the second, y to the negative 1, 3 to z to the 7th. So I just subtracted those. Now there's one more problem. There's a negative exponent. So I'll keep the fraction line. Everything is okay and simplified. There's no like bases, so everything stays where it is except the y moves down. And that's your answer. So let's look at 28 now. So I have a negative exponent here, so I'm going to get rid of it first. So 2 stays, h cubed stays, j to the negative 3 moves and becomes positive, k to the 4th stays. Now I'm at 3. 3 stays, j stays, k stays. Now simplify that. If I look on the top, nothing goes together. No like bases are the same. No bases are the same. Down here, however, I have 2 j's, so I can put those together. So everything on the top stays the same. I'm going to pull my 3 in front. J to the third, and j, if it doesn't have an exponent, there's a 1. And remember to add right there. Some people make a mistake when it's a 1. So that would be j to the 4th, because I add 3 plus 1. And k doesn't have anything. So now there's one more simplification, because I don't have anything on the top that goes together nor the bottom, but these are stacked. So I can subtract those. So I'm going to come down here. That's going to be 2h to the third. K, since this is the same, it's 4 minus 1, and that takes care of that, over 3j to the 4th. So that becomes, let me come over here, 2h to the third, k to the third, over 3j to the 4th. And that's it. Alright, and last one. Evaluate everything. You have negative exponents, so see what needs to move and what needs to stay. So the 3 doesn't have a negative exponent, it stays. X to the third stays. Y to the negative 1 moves down and becomes positive. Z to the negative 1 moves down and becomes positive. X to the negative 4 moves up and becomes positive. Now I'm going to talk about this y to the 0. Anything to the 0 power becomes a 1. So this becomes a 1 and this becomes a 1, and I'm multiplying. So I could put times 1 and times 1, but anything times 1 is just going to be itself, so the 1s don't change anything. So let's look at the top. What could go together up here? The x and the x. You're multiplying those, so you add their exponents to get 7. And then down here, y and z don't go together. You don't add these, they're multiplying. But I could just put y, z, because 1 times 1 would just be 1. And 1 times that would just be y times z. And there's nothing else you can do to that one.